Alright, now we're on page 447. We're going to do a couple of the problems for page 447. And then you'll be able to work on the odd number problems once I finish those problems from page 447. So we're going to start with number 8 on page 447. We're supposed to refer to exercise 7, and we want to construct the 90% confidence interval. Confidence level we're using is 90%. Estimate of the difference between the two population proportions. So P1, P2. Alright, so if we refer to problem number 7, again we're going to use the to construct the confidence interval 2 prop z test, stat test, 2 prop z test, 2 prop z interval for the confidence interval. And we're going to enter the information from 7. It says that employees is going to be 1, so 436 workers, so that's N1, 436. Of the 436 workers, 192 of them said that it was unethical. 192. And then of the 121 bosses, 40 said that it was unethical. So that's our X2. We are using a 90% confidence level, so that's 0.9. Hit enter. And there's our confidence interval, 0.0293 to 0.190. Again, we are 90% confident that the interval from 0.0293 to 0.190 contains the true difference between the two population proportions. Let me just fill this in. This was N1 was 436, X1 was 192, and then out of the 121 bosses, 40 of them. Alright, last problem is number 10, same page. For number 10, we're referring to number 9. We have two independent samples here, two independent populations. And it says, in a study of women with coronary heart disease, the following sample results were obtained. 10,239 low physical activity. There were 101 cases of coronary heart disease, 101. Among the 9,877 women who had a higher level of activity, 56 cases of coronary heart disease were found. So we want to test the claim. Again, this is number 10. We're just using the information from number 9. We want to use a 0.05 significance level to test the claim that the rate of coronary heart disease is higher for women with lower levels of activity. So lower level was our 1. Is greater than, the lower level is greater than, the rate of coronary heart disease is higher for women with lower activity. Alright, so the opposite of this would be P1 is equal to P2. Alternative hypothesis, null hypothesis. Here we go. So for this, we're going to use 2 prop z test. We're going to test the claim. Stat test 2 prop z tests is 6, and we have to enter this information because these are two different problems. So N1, well, X1 is 101, N1 10,239. X2 is 56. N2 9,877. And our alternative hypothesis is that P1 is greater than P2. P1 is greater than P2. Calculate. Write down our test statistic and p-value. 3.38. P-value is 3.63 times 10 to the negative 4. 3.63 times 10 to the negative 4. Let's check that. Alright. And now we want to compare this p-value to our significance level. As we can see, it is less than or equal to our significance level, so we reject the null hypothesis. Now we can write our formal conclusion. There is, since we are rejecting the null hypothesis, sufficient evidence to, our original claim is the alternative hypothesis, so we write support. The claim that, restate the original claim, the proportion of coronary heart disease in the lower activity is greater than the proportion of heart disease and the proportion of heart disease in lower activity subjects is greater than those who have a higher level of activity. And lastly is our critical value inverse norm. Since this is a normal distribution, critical value is in the right tail, so we're going to use 1 minus alpha. 1 minus 0.05 is 0.95. So we plug that into our calculator. Second vars, inverse norm, 0.95, and 1.64 is our critical value. Alright, all done.